time for the next session. So please take your seats or get the heck out of here. One or the other. My name is Eric Pfister with TRW, and today we get to learn more about highway interchanges from Kyle Chism and Steve Nicaise with Parsons and Amanda Desmond and Emily Deason with KYTC. This is virtual, of course. So any virtual questions out there, please feel free to write them in. I'll be able to see them and ask, and then later we'll open up questions. So take it. Thanks, guys.
Hi, my name is Deason. I'm project manager for ORX in Henderson, and today we'll be doing kind of two mini sessions. Steve and I will be doing the ORX interchanges in Henderson, and Kyle and Amanda will be doing the 255-64 interchange in Louisville. So the ORX project purpose is to connect I-69 connections between Kentucky and Indiana. We've taken a phased approach to this mega project. Section 1 is essentially the Kentucky approach, and it is in construction right now. We're awarded in the 2021, and we're in construction at the moment. Section 2 is the Bi-State project, that is the actual Ohio River crossing. And then section 3 is essentially the Indiana approach, and they are in preliminary design at the moment. Steve will be going through the interchanges and how they really, evolved and were modified through the EIS process. And he was there and he's intimate with all of that, so he's going to do the majority of the speaking for us today. But we do have 6 interchanges. The 3 at the bottom are existing, 425, the Audubon, and 351. Then our new interchanges are in the orange. They are US 41, US 60, and the Veterans Memorial Parkway over in Indiana. So this time I will turn it over to Steve.
Sure. So we're going to talk about how these interchanges were identified in the EIS process, and then modified through the FEIS process, and now in the preliminary design and construction. At Kentucky 351, we're completely rebuilding this existing interchange. And just south of 351 is Kentucky 2084. And early in the NEPA process, we identified the need to convert this segment of the Penny Route Parkway to interstate standards, and the separation between these interchanges was so close that a new auxiliary lane was needed on the northbound side. Let's see if I can point. So from the 2084 on ramp north to the existing loop ramp exiting at 351. Obviously, operational issues were a concern, weaving and those sort of things. At US 41, we're utilizing US 41 to the south is I-69. I-69 then goes overland, beginning just north of the CSX Railroad, which is here. So we have an overland new alignment section. And the interchange with US 41 in our earliest iterations was about a mile to the east. And this was to provide for improved operations of the interchange and to expand the areas, developable areas for the city of Henderson, which was the goal for the city of the county. However, in going through that process, we've heard from the business owners on the US 41 strip, which is north of here on US 41, about their concern for the added travel distance for northbound traffic to drive an extra mile east and then come back a mile west to get to the strip, and for southbound traffic, again, to go a mile to the east and then another mile to the west. So in the DDIS, we presented this option, which was a system level interchange right near the existing US 41 location. It's also crossing a wide floodway. New Creek runs through here, and the floodway is very wide on New Creek. So the bridges for the main line and the ramps crossing New Creek are shown very, very long bridges, which drives up the cost of the interchange. This contributes to the overall cost of the project and the affordability of the project. At US 60, we were constrained by two significant historic parcels, this large farm tract here and another historic property here. And we were threading the needle there, as well as there's a high voltage power line that runs right through there. So all those constraints contributed to how this interchange was conceived. We got a traditional diamond interchange relocating US 60 to the south, and because the CSX Railroad is nearby, because US 60 had to be high to get over the railroad, this alternative had US 60 continuing high across the interstate, with the interstate being basically at the level of existing US 60. Now, south of here, this is all floodplain. And so the highway is elevated above the floodplain, obviously. And so is US 60. So the new US 60 was 2 levels up. So it was a considerable amount of fill and work to construct that. Up at Veterans Memorial Parkway, existing I-69 runs along here and currently ends right in this interchange. So we're realigning 69 to go south. And this whole area from just about the existing alignment south to the river is all floodplain. And there's a creek that runs along this this bank of the floodplain, Eagle Creek, and environmental mitigation areas, wetlands, and all sorts of things. The levee that protects the city of Evansville runs along the north side here, so we're constrained by the levee and work along the levee. A large pond area right in the middle of our interchange, and the spacing between this interchange and the existing 41 interchange and the Green River Road interchange, which is just off the screen here. This graphic shows the floodplain and the flood water flows across the floodplain. And we were looking in the DEIS phase to identify how much of this alignment could be built on fill. Obviously, the fill would be less expensive than the structure. And it's approximately 3 miles across the floodplain here from the Kentucky bank to the Indiana bank. And these small areas here were identified as potential islands that could be built to transition between the bridge types. And but that's the maximum size of fill that we can place in the floodplain without causing upstream flooding impacts. Sorry, and this graphic shows the floodway and floodplain at the Canoe Creek crossing, the US 41 interchange that I described earlier. So at the DEIS, we explained all the different alternatives that we were looking at. There was strong public support for the central alternative. However, there was feedback to improve the Kentucky 351 interchange, improve the northbound exit, and to create a gateway for the city of Henderson and US 41. They were looking for further efforts to minimize effects on local traffic and at veterans to reduce the traffic distance and improve speeds for the main movement, which was eastbound Veterans Parkway to northbound 69. And so we conducted a value engineering process just following the DEIS. And through that process, we came up with a number of interchange options to look at to right size these interchanges to hopefully reduce the project cost to an affordable level and to make these improvements that the public and stakeholders were asking for. And we're looking at things like in the US 41 interchange, southbound traffic, we had a long, expensive ramp to connect southbound 41 to northbound 69. Doesn't make a lot of sense, but to be a full service interchange, we needed that movement. But it did add considerable cost, so the BE process that considered options for eliminating that. Through we did what we call an interchange option study, and we came up with a recommendation to look at a service level interchange rather than a system interchange that was in the DEIS, a service level interchange, a traditional diamond interchange at this location that would provide access to the property south of the interchange as well as to the north, that would hopefully improve the development potential around this interchange. Up at Veterans, we're looking at options there as well. We talked about that eastbound traffic to northbound 69, basically the eastbound movement through here. And in the DEIS option, that traffic would travel along this long two-way ramp bridge to continue east. And there was concern about that, and the travel distance, the speeds, etc. So the options we were looking at prioritize that movement through the interchange. We looked at several options here, including a 3-level interchange and also a 2-level interchange with an intersection or roundabout considered at this location. When we started the preliminary design for section 1, the Kentucky section, we met closely with the city, the school district. At this interchange, there's a major school, the Henderson Middle School, right near the interchange, and then the high school is off the screen, just on the opposite side of the road to the east. But we looked at different options for the interchange, including a SPUI type interchange to eliminate this loop, northbound loop off ramp. Also to eliminate the 2084 interchange altogether and have all the traffic exit at 351 and continue down 2084 through a roundabout. So in going through that, we came up with this recommendation for a triple roundabout. One at the ramp terminals and the traditional diamond interchange, and then another one to the west in front of the middle school and connect 2084. And in doing that, we eliminated all the bridges and ramps in the 2084 interchange to the south here. And then continue to meet with the city and identify their gateway needs, and we came up with a concept for the landscaping that was then brought forward into the design build procurement process as guidelines. We established the budget for this work, and using that budget, the DBT will work with the city to prepare the final design for this gateway. At US 41, this interchange would work fine once the project is built across the river, but the phasing of the project is such that section 1 will be built and online operational for about 5 or 6 years before the completion across the river. And so all the northbound traffic that one day will continue across the river needs to exit here and continue on US 41 to the north. And likewise, all the southbound traffic will be coming down US 41 and continuing on 69 to the south. The diamond interchange, of course, would cause traffic issues with backups to make those movements at a traditional diamond interchange. So this concept was revised slightly to include a continuous ramp, northbound off ramp in the trumpet style on this side of the interchange, and to revise this southbound to northbound ramp to a loop. We talked about that being the minor ramp that had the least amount of traffic, and So this will be retained in the final configuration. And we do have plans for an ultimate configuration that once 69 is completed across the river, Kentucky can consider a modification here to extend US 41 down to Kinsey Lane here and convert this to a service level interchange. We show a detention basin in here. And through our analysis of the Canoe Creek floodplain and floodway and the impacts of the project on the floodway, the mitigation that was developed was to build a large, I believe it's 120 acre detention basin here. So significant size detention basin. It's actually 2 basins. And that will mitigate the impacts and allow us to reduce the size of the bridges over Canoe Creek. The existing bridge on US 41 just spans the creek itself, it doesn't span the floodway. And so the new bridges will have a similar spans to the existing bridge. And this will have a tremendous benefit for the project costs. Also, these detention basins become the major source of fill for the highway across the floodplain. So there's no need for offsite borrowing. Up at US 60, we had 3 design build teams looking at this in the procurement phase. All 3 came up with an NTC that basically eliminated the need for the CSX bridge by keeping US 60 at its existing grade and sending I-69 over top. And by doing this, they were able to retain the existing bridge on US 60. And it also saved on the order of 300,000 cubic yards of earth because all the large earthworks that were required to bring US 60 up 2 levels over the floodplain. So this ATC had a considerable benefit on the project cost. And then up at Veterans Parkway, we went through the IAD process, interchange access document, as it's called in Indiana. And we looked at a number of different options, and it recommends a system level interchange up there. It dismissed the service level with the intersection between these 2 ramps. We just started preliminary design, and we're looking at the benefits of stacking the interchange to perhaps make this northbound to westbound ramp the 2nd level, and this eastbound to northbound ramp the high level. But that work's still underway. This project will be flat in 2023. And with that, I'll hand it over to Kyle and Amanda.
Good morning, I'm Kyle Chism with Parsons.
Good morning, I'm Amanda Desmond with KYTC. And we're going to talk about that 265 I-64 interchange. And we say that every interchange has a story. Well, this one actually has a history. When I took on this project as project manager in 2016, it had already been on the books for 20 plus years. They're asking why. Well, we have a system interchange, and the dollar amount for the ultimate build was astronomical. And so in normal KYTC fashion, we phased it out, and even the phases were out of reach as far as funding goes. So what we did is actually re-advertise, and we were going to go with our performance-based flexible solutions. It's actually one of the first ones in the state. So very instrumental in that. And goals were to improve the operational and safety characteristics, and then also address short leading segments, and acceleration and deceleration lanes. So here's the project footprint. As you can see, we're going from Ronald Road, going from south 265 to north, just before US 60. And then on 64 from Lincoln Baker to the west, and then English Station Road, overpass to the east.
Thought this might be easier. All right, so if you ever driven this interchange, the AM or the PM peak, you're gonna see backups. So the AM. Yeah, so in the AM, you're gonna see backups on 265 south all the way down to Taylorsville Road. In the 265 northbound, north traffic coming southbound 265, you'll see traffic backing all the way up beyond US 60. And that causes a lot of weave issues within the interchange here, particularly between ramps A and H. And the backup is so bad with the traffic coming northbound here that it actually impacts the smaller amount of vehicles that are coming westbound or eastbound 64 to go to 265 northbound. So that we usually use an issue in the morning. In the evening, your backups are really just everybody just parked on I-64 eastbound, and it goes all the way back to Blankenbaker at many times. Got a couple of things. So with the project, we wanted to minimize the right-of-way impacts. The first alternative that was studied actually had no right-of-way impacts. However, we still had some minor impacts that we could use. There are also some very significant utility impacts that we did not want to get into. It's 254 here. There are some very high power LTE towers, and then there's a AT&T legacy fiber line, which the splice points for the manholes are just east of the interchange and then over near Blankenbaker. And so if you got into that at all, which had very minimal cover, very close to ramp B here, you're going to be relocating that at a very high cost for over a month. When we were looking at the getting into studying this interchange, we want to start with the crashes. And so first thing we want to do is we want to break out our fatalities and look at them from a user-related standpoint, but also look at them from a roadway related. Sorry. We as engineers, we can fix roadway related issues. We cannot fix user related issues. We cannot make someone drive slower. We cannot make someone get off their phone, not take a phone call, something like that. But with that, we identified, 3 hotspots. Hotspot 1 at the part of the interchange where I was speaking about the weaving issues, and hotspot 3, which is the backup predominantly at the interchange here. We'll talk about those more. And then
We had hotspot number 2. Actually, we had to include that because it's included in the original ONSI. How it impacts US 60, but it being so close to us.
And all of these hotspots are really based on the EMP traffic. The crash problem is not a major issue in the mornings, it's more of a PM issue.
Okay, so this is actually a view of the crash history on 64 weave and the 265 weave with the loop ramps. And if you can tell, there's a lot of backup here. And so what would actually happen, and I've been witness to it, and I've gotten phone calls from it, is actually people would use the shoulder. And yeah, thank you. They use the shoulder and actually block the other functionality of the other loop ramps. And so that was another thing that we were trying to do, was improve the safety of the interchange.
And I drive this, this is on my commute home every day. So when you're traveling this, there's 3 lanes on 64 eastbound, and then you have ramp B coming off, creating a lane. The left lane, you're wanting to travel 55, 60, 70 miles an hour, depending on who's driving. Whereas the right 2 lanes, The far right lane is predominantly standstill, and it's stop and go traffic. So you've got people that are, trying to come along here and then gonna hit their brakes and try and jump over the very last second, which is causing, you've got a lot of, high speed differentials. I know that's a buzzword from Woodville. So you're gonna, with those, you have a higher, crash, significance, due to that great differential of speed.
Okay, so this was actually the Cadillac version of the original Interchange, with the hefty price tag on it. It was originally 4 levels, fully directional ramps, 50 miles an hour ramps. And as you can tell, it did take up a lot of right of way, and you can see that we're gonna have to have significant utility involvement on that. Another thing to note, it was 5,100 feet of structure on this as well. And then it was a lot of issues with the lighting. It was actually going to be high mass, but you're going to have to special order it and have special heights for it for the 4 levels. And so, as you can see, the ultimate bill had a price tag back in 2017 of 170 million. And so if you could, we'll just remember that 170 million because it'll be coming back around. But we did break it down into actually 4 different alternatives that we came about. We're going to be discussing those. And so the first one was actually something that we came about in KYTC central office and actually through the district as well. It's called a spill-through flyover. It's something similar to what you would see if anybody's from Lexington, New Circle and Brazil Road. We kind of, the big goal for this was actually to remove 2 loop ramps and provide better fully directional. This was still single lane for each of the loop ramps, so it didn't look at capacity, it looked at actually throughput. Second alternative was actually the spill-through flyover, but we were actually looking at capacity of each of the ramps. So ramp A, ramp B, ramp H, and ramp D, which were all the hot spots that you saw before, needed 2 lanes in each direction. But as you can tell, it was actually going to be a ramp A was going to be 2 lane loop ramp at 25 miles an hour. All these were 25 miles an hour design speed.
So when Parsons was selected to take us through preliminary engineering, the partial turbine was one of the solutions that we were, most excited about for a lot of reasons. One, it kept your outer ramps at 50 miles an hour, so it kept those outer ramps at high speeds. 2, it provided the needed capacity for all of your 2-lane ramps, A, B, D, and H. We were able to take a 4-level interchange and reduce it down to a 2-level interchange. And we did that by taking ramp. So if you driven past the interchange, when you exit off of either ramp C or you exit off of ramp D here, you actually go down before you start to come back up. Well, that was key in us being able to get the ramp B and ramp A underneath the 265 without having to do, significant cut. Because you think, okay, you're going to be, you need to bring this up and go over. Well, in doing that, you're going to be creating a lot of retaining wall and a lot of unnecessary structure. So by keeping this at 2-level, it has so many different benefits. The only real concern was just, are we dealing with the drainage through here? So with this option, it addressed the capacity. It kept the 2 existing loop ramps E and G, which were the lower movements within the interchange, but it did not address the leaving concerns and the need for the additional CD. Initially, this was the CD lanes out on 265. That's where we came with the alternative 3B, which is the partial turbine with braided ramp C. So with our project scope, we brought in, we utilized streetlight data to gain a true understanding of the origins and destinations within the project limits. We utilize that data then to better forecast where our traffic's going to be. And in recognizing in doing that, we recognize that nearly 80% of the traffic that was going 64 westbound, 265 north, they were going beyond US 60. And half the traffic that was coming 64 eastbound to 265 northbound, they were exiting at US 60. So by bringing ramp C in and having it merge into the 265 traffic before having ramp H come in at all, that eliminated a significant weed and eliminated the need for those expensive CD lanes. Additionally, from our traffic forecast, we recognized that the throughput of 64 didn't need to have 3 lanes currently out there. It only needed 2 lanes, and it really 2 was a stretch, but you don't have single lane interstates, right? So we worked closely with Thorough Highway, and so the way we designed this was we provided option lanes for ramp D, such that you have the 3 lanes coming in, and then it was a 2-2 split. And then same thing when ramp D came, you had 3 lanes going out to a 2-2 split. So you could physically get in the correct lane on 64, travel all the way through here, and then you didn't have to change lanes to exit off of US 60, or you could have an option lane on US 60 and continue on north. So with any project, you have engineers, we're quantitative driven, right? We're looking at quantities. That's what our final plans are all driven by. But you need to have a qualitative analysis that you can compare things to. You want to compare apples to apples. So we looked at 12 different categories, assign the level of, or the value to those categories appropriately. So traffic operations, driver expectancy, safety, those were all key, key things that we wanted to give a higher value in this analysis. But right-of-way impacts and environmental impacts, long-term maintenance, those were not as, were not as critical in terms of our analysis here. We also looked at the expandability. And the reason we did with that was because the no build and alternative 1 requires significant reconstruction if we ever had to add in that 3rd lane back on I-64.
So on that previous slide, we chose
Yes,
alternative 3B.
yes.
But go to the next slide. So how did it get built? Well, we actually went through the contract, picked alternative 3B, and there was multiple projects, 4 projects that were being built around the same time. And so we decided to go design build on it. And so it included 64 and the Gene Snyder, and then the I-265 widening from Taylorville Road to I-71, I-71 CD at 265, and then the I-71 widening from 265 to Kentucky 329. And since they were all around the same time, they were actually going to be conflicting MOP. And so it was actually going to be beneficial to the county to go ahead and include all those in one project. And so I tell you to remember the 170 million for the ultimate build. Well, this whole project design build was 180 million. So we literally got 4 major projects in Louisville, Kentucky for basically the same price as the ultimate bill for one system interchange.
And that concludes our presentation. If there's any questions for I-69, Emily and Steve are here, or if there's any questions for the Snyder 64 interchange, Amanda, I'll be happy to answer them. I think people are ready to leave. All right, well, thank you very much today for your time. Really appreciate the opportunity to present here.